Hello, this is Russell Tackett, Senior Electronic Sales and Application Engineer for HydraForce. This is video 2 on the series of setting up an ECU-0809 with HF Impulse. As the first video, we did run through a basic setup, which we see on the screen here, of an analog input running through a couple scale blocks to drive a couple outputs, and having a couple monitor blocks there to monitor what's going on in the program. On the second video, I want to talk about the slope block, and this is kind of an advanced idea. So we see on the scale blocks here for output A and output B that I had to hard code in what would be the minimum current and maximum current going to that valve. So if you had created this program and given it to your customer, you would have to give them this configuration for them to be able to modify this. And this may not be ideal. It may be better to have some retained blocks that allow you to give them a service tool that they can monitor or modify the value of the retained blocks, and you wouldn't have to give them the source code. How this compares to the Code Assist series of videos, we saw in there how we were able to do the same thing with variables that we could access through a service tool. So want to do the same thing here. The documentation for this video is also located in the ECU-0809 HF Impulse First Project. I'm in section 4 right now, the HF Impulse Creation Advanced Setup. The example above, or the one we did in video 1, would require releasing the source code to the customer to make modifications to variables such as min and max currents to the value. This may not be ideal. It may be ideal to have a service tool that had those parameters that could be adjustable. So start talking about the slope block, and I want to bring in the document that is going to be used to reference this video. Sorry. So we're in section 4.2, using the slope block. So the slope block is going to allow us to give a variable to kind of create our own slope from the retained values and for also the voltages in the analog input. So what I want to do is I want to kind of make our screen a little bit larger. Let me go ahead and pause the program and I'll make the screen larger. Okay, so the screen larger isn't going to work right now. Let's go ahead and see what we can do with the screen as it is. So I'm going to go ahead and organize this a little bit better to maybe make it a little more flat. We can get more information on our screen. So once again, selecting these two, holding down the control key, and then I can move things around as I like. Just kind of organizing a little bit here. Trying to keep things in line because I'm kind of picky like that. Now, I could take these two blocks and I could align them, select them both and doing a right mouse click and align vertically. Okay, so both of those are lined up now. Okay, so what we want to do is I want to bring in a slope block. So that's under service control, under utility functions, slope. Okay, we see that we have an input, we've got an X1, Y1, X2, Y2, and then an output. Okay, so what I'm going to do is I'm going to go ahead and bring in some constant variables because I'm still going to use the constants of the joystick. Now I could put those in retained values also, but for right now I'm just going to make it a constant. Value 2400, which represents 2.4 volts. Control C, Control V. 500, which represents a half volt. If you'll recall on scale block A, we kind of had to build it backwards, right? So at a lower voltage, I got a higher current. At a higher voltage, I got a lower current. So I'm doing the same thing here. My X1 would be the 2400, the X portion of the curve, and then my X2 would be 500. Want to go ahead and put the value of my analog input into the slope block. And just as we've seen before, so I highlighted the box I wanted to draw a line from. I grabbed the output connection point and then drew, with a left mouse click, pulled it to wherever I wanted it to go. Okay, a couple retain variables. Retain just says it's going to be able to hold that value on a power cycle. I want to label this one output 8 minimum. And I want to give it a value of 300. It's just an initial value. So whenever we go online and then we change that value, then it would go ahead and keep that on a power cycle. But if you re-downloaded a configuration, it'll revert back to that 300. Put him on X1. Try to kind of draw it in line here. I'm going to bring in another retain variable. We'll call this one output 8 max. And give him a value of 1100. Connect him to Y2. Okay, all right, so what we're going to do now is we're going to, depending on the value of the analog input, we're going to go from a minimum value of 500 to a maximum value of 800, and then modify the output to be swinging between the minimum value of output 8, 300, and maximum value of output 8. Now, different to the scale block, whenever you had exceeded either less than a half a volt or greater than 2.4 volts, the output went to 0, as we can see on the graph. The slope block doesn't do that. So it goes between the 2 points, the X1 and the X2, and then gives a current Y1 and Y2. But if you go outside of those blocks, it just continues going. So that's not exactly how we want it to work. So I want to go ahead and turn this block on and off depending on the setup of the system or how we're out of the system. So I want to grab a select block. And what I'm going to do is I'm going to make sure that the analog input is greater than 500 volts, but less than 500 millivolts or half a volt, or less than 2400 millivolts or 2.4 volts. So I'm going to go here into my compare section. I'm going to grab a greater than and a less than block. Okay, so I want my analog input 1 of the greater than block, input 1 of the less than block. I want to make sure that my analog input is greater than 500 or also less than 2400. Okay. Select these two and kind of push them over here and make it look a little better. I'm going to put an AND block, so a Boolean function, AND block. And then the output of the greater than block will go to the input of the AND block. The output of the less than block will go to the input 2 of the AND block. And then that will drive the true or false for my select block. Okay. So yeah, I had a wire there that kind of went out to lunch. It's not connected to anything. Once I save it, that'll go away. So the slope block, if it's true, I want it to come out as the true in. And then I'm going to create another monitor block for us to monitor what's going on here. So monitor 3, you see it automatically incremented. I'm going to call it output A slope, output 8 slope. Now, one thing I want to do, I want to go ahead and put a variable of 0 in the false in. It may work okay as far as not having an input into the false input, but just to to try to keep your programming clean, I always try to put in a particular value that I know what it'll be into a variable. So I copied my 500 here. I'm just going to highlight it and be a 0. Okay. Okay, so what we've done, we've taken our analog input. You know, I've left this code up here just to kind of you know, just as a reference. And then we've added the slope block. So the slope block allows us to add these retain variables to be able to modify the minimum maximum value of current in our service tool. And if we go over to service tool now, we see that we have two values. We've got a retain 1 and a retain 2, which is a value of 300 and 1100. It's going to say that, okay, right now, if we went online, we would be allowed to modify that from 0 to 65,535. But right now, the preset values are 300 and 1100. Okay, so we've got the minimum maximum values going to the slope. We're making sure our analog input is between less than and greater than with this and block, and looking at the select. So when we would download this code, we should see the same value of monitor 1 for monitor 3. Okay. I'm going to pause the video and go ahead and put the same logic in for output 5. It'd be kind of boring to watch me just code that in. So I will put us on hold and I will be back shortly. I have added sections for looking at the slope to the slope block of output 8 and output 5. So how this works is we're looking at the analog input. It's going in a less than or greater than block, so less than 2400, greater than 500. This represents 2.4 volts and a half a volt. If this is true, then I turn on my select block to take whatever value is coming out of the slope block going to monitor 3. So monitor 1 and monitor 3 should give us the same value. Did the same thing for output 5. You know, I'm less than 4500, greater than 2600. I've got a couple more retained variables here coming into an AND block to a select block to be put out on monitor 4. Also, if we look at the service tool, we notice that we have all 4 retained blocks now. We've got monitor 1 and monitor 2 and input 1 or input 4 and output 7 and 8 and 5 and 6. We had those from the first video, but now we've added monitor 3 and monitor 4. I've already downloaded the code into the controller to save us a little bit of time. So if we log on, come down to our monitor section, we look at input 4 and then monitor 1 and monitor 3. When I change the value of the analog input going down, we can see that I have the same current going to monitor 1 and monitor 3. If I change my variables from monitor 2 to monitor 4, change the variable input, we can see I have the same value. So talked about this before, we can turn off auto scaling to give us something that's a little more reasonable. So if I set that to 5,000, monitor 2, we know he could be a value from 300 to 1100. So maybe I put 250 and 1150. And then do the same thing for monitor 4. When I change the input now, we see that the scale doesn't bounce around as it did before. Put it back into a neutral position. Want to go ahead and log off. Always want to save your configuration before you leave. I hit close, and then I'm going to open my service tool. Parameters. So we have all of the retained values and everything that we saw offline. Now, I don't know that I said this before, but every time you make a change and need to have new variables, you always want to export that service tool. So I've exported it and opened a new service tool. If I log on, change my variable input, we see that output 2 and output 4, monitor 2 and monitor 4, and output 5 all have the same variable value. If we go lower on the voltage, then the same thing. Output 7 and 8, 1 and 3 are the same. Now, if we went over here and said, okay, I don't want the retained value or the output 8 minimum to be 300, but maybe I want it to be 500. Hit 500, I have to flash parameters, which actually stores it in the 0809. Now, when I try to drive variable 8, I don't have it tied to the output, but we'll see that monitor 3 and monitor 1 will be different values. So notice that monitor 1 comes on at about 300 milliamps, monitor 8 comes on, monitor 1 comes on at 300 milliamps, monitor 3, which is out of the slope block, now comes on at 500 milliamps. This concludes video 2 on the advanced setup of the HF impulse using ECU-0809. Lots of good information is in the ECU-0809 programming reference. The basic way that you're programming this is the same on all the ECDR controllers for the 101, the 201, the 506, and the 203. But there are some minor differences. The biggest one being that those other controllers are not using codices. Good luck, and any questions, please get a hold of HydraForce. Thank you.